Hello students, myself Pratik Kadam, Assistant Professor, Department of Information Technology, K.K. Bagh Institute of Engineering, Education and Research, Nasik. Welcome to the lecture series on subject Design and Analysis of Algorithm. And our today's topic is Basics of Algorithm. So, the learning outcomes of this video is that by the end of this video, you'll be able to understand the characteristics of algorithm, you'll be able to understand the structure of algorithm, you'll be able to represent algorithm in different ways, and you'll be able to explain the algorithm analysis framework like time complexity and space complexity. So let's start with what exactly is an algorithm. So the algorithm is a set of rules which are used to solve a real life problems. The term algorithm is derived from the name of Persian mathematician Abu Zafar Muhammad ibn Musa al-Khwarizmi, who lived sometime around 780 to 850 AD. He was a teacher of mathematics in Baghdad. Also, the first ever algorithm was developed by Babylonians for the factorization of number and to find the roots of equation. After that, Euclid had proposed a famous algorithm for finding the greatest common divisor of two numbers, and thereafter there were so many algorithms for different problems. So once the algorithm is given to you, it is very easy to program the solution. Your algorithm bridges the gap between the natural language description of a solution and the syntax of programming language. So let us see the textual definition of the term algorithm. An algorithm is a set of steps of operations to solve a problem performing calculation, data processing, and automated reasoning tasks. An algorithm is an efficient method that can be expressed within finite amount of time and space. So now that you have understood what is algorithm, you might be wondering why should we study the analysis of algorithm? As we know different algorithms, why there is a need that we should know or we should do the analysis of the given algorithm. To explain that, I'll just give you one simple example. Let us say you have a plot of land and you would like to build a house on it. So you just don't go directly on that particular land and start constructing your house. First, you go to the architect. So architect here is a person, let us assume he is basically designing the algorithm. So that architect gives you various designs for the different plans of your house. You could also consult any other architect and see his designs, and the best design that suits for you or the one which you like, you select that. So this is why you also need the analysis in the algorithm, because you whatever problem statement you have, you want the best solution for that given problem statement. After analyzing the algorithm, you'll be able to understand the theoretical estimates of resources that are needed, because to run that particular algorithm you'll need some computational resources, right? And also you should have an insight about which algorithm suits the best for you. Whoa, this is fun. So do you think that this is really a fun? Yes, indeed. This subject is really fun because it actually makes your brain work and think of different perspectives. So before we see the details of algorithm, let us first see what are the fundamental stages of problem solving. Problem solving is both an art and a science. The problem solving process starts with the understanding of a given problem and ends with the programming code for the given problem. So following are the stages of the problem solving. So the first stage is understanding. So study of your algorithm starts with the primary questions of computability theory, that is the given problem solvable. Therefore, a guideline for problem solving is necessary to understand the problem fully. Hence, a proper problem statement is required. Generally, computer systems cannot solve a problem if the problem is not properly defined. So that is the reason understanding is the first step, because you need to understand the problems first. If you don't understand the problem, you cannot provide a solution for it. The second important stage of problem solving is planning. In this stage, basically you model a computational model, and apart from this, in this stage you try to do the organization of data. So whatever data you have regarding that problem statement, you try to gather that and you just try to plan how you are going to deal with this particular problem. Then comes the important step, that is designing. Algorithm design is the next stage of problem solving. The following are the two primary issues that you try to solve in this stage. So first one is the Algorithmic design. So algorithmic design is a way of developing algorithmic solutions using an appropriate design strategy. Your design strategies differ from problem to problem. And the next one is the algorithmic specification. After the algorithm is designed, it should be communicated to the programmer so that the algorithm can be coded as a program. This page basically is known as the algorithmic specification, which comes under the designing step. The next step that we have is validating and verifying. Algorithm validation and verification are the methods of checking algorithm correctness. An algorithm is expected to give the correct outputs for all valid inputs. Algorithm validation is a process of checking whether the given algorithm gives correct outputs for a valid inputs or not. This is done by comparing the output of an algorithm with the expected output. Once validation is over, algorithm verification or algorithm proving begins. Algorithm verification is a process of providing a mathematical proof that given algorithm works correctly for all instances of data. Once validating and verification is done, the next stage that we have is the analyzing. In analyzing, we study the complexity analysis, which is a very important step because complexity analysis is useful for following two purposes. First is to decide the efficiency of a given algorithm, and the second one is to compare algorithms for deciding the effectiveness of that particular algorithm on the given problem statement. And once the analyzing is done and once you have finalized the algorithm which suits best for your problem statement, comes the implementation step. After the algorithm is designed, it is expressed as a program and a suitable programming language is chosen to implement the algorithm as a code. The most important thing that we should do is like whatever programming language we select, it should be independent. Your program should not be related to only one particular OS or one particular platform. It should work for each and every platform. So that comes under your implementation steps. So these were your fundamental stages of problem solving, that is understanding, planning, designing, validating and verifying, analyzing, and finally the implementation. So now that you have understood the fundamental steps of problem solving, let us discuss the characteristics of algorithm. So the first characteristics is input. Your algorithm may take 0 or more input arguments. Depending on the problem, the input may be scalar, vector, array, tree, graph, or some other data structure. Input plays a very vital role for any algorithm because depending upon what is input, we can predict the working of the entire algorithm. The next characteristics that we have is the output. Your algorithm reads input, processes it, and produces at least one output. So, depending upon again the problem being solved, the output may be of the form of scalar, vector, array, tree, graph, or some other data structure. It is again one of the most important character because we design an algorithm to get the efficient output. The next characteristics that we have is definiteness. An algorithm is basically characterized by its definiteness. Its instructions should be clear and unambiguous without any confusion. All operations should be well defined. The next characteristics that we have is uniqueness. An algorithm should be well defined and ordered procedure that consists of set of instructions in a specific order. The order of the instructions is important as change in the order of execution leads to the wrong result or uncertainty. The next characteristics that we have is correctness. Your algorithm should be correct and it should give the correct output for different inputs or varied inputs. The next characteristics that we have is effectiveness. An algorithm should be effective, which implies that it should be traceable manually, which simply means that in case if any person wants to check your algorithm manually, he should be able to do it. It should not happen that your algorithm is so complex that it can be executed with the help of computer, but manually it is very hard to trace. So that won't be good algorithm. So your algorithm should be effective. The next that we have is finiteness. An algorithm should have a finite number of steps and should terminate after executing the finite set of instructions. Therefore, finiteness is one of the most important characteristics of an algorithm. It is quite simple, right? Let's say you are an owner and you are asking a person to design a solution to your problem, and that person is designing solution. Let's say you want to complete a certain work, and if there are two people, one person is giving you a solution wherein to complete that particular task it requires around 30 days, and the other person is giving you a solution which completes your task in just 1 day. So you would think like, yeah, I would go with that first person because it is having finite steps. I won't need to wait for 30 days. That is why the algorithm which is giving you the less amount of step, less complex, that is selected the most. So apart from this 7 characteristics, few more characteristics that we have is, first is simplicity. So whatever algorithm you design, it should be very easy to implement for any person or any program. And the next one that we have is generality. Your algorithm should be very generic, independent of any programming language or operating system, and should be able to handle all ranges of input. It should not be written for any specific instance. So let's say you have created an application. So nowadays you all are using Android phones, right? Or a few of you might be using iOS phones. So sometimes it happens like there is a particular application which works great on your Android phone, but it does not support your iOS platform. So we don't want such algorithms. We want an algorithm to be implemented in such a way that it should work on each and every platform. So now that you have understood the different characteristics of algorithm, let us see how these algorithms are represented. So there are 3 ways in which you can represent the algorithm. The first one is the natural language. This is one of the easiest way of writing an algorithm. It contains an English-like statements. This representation completely omits technical aspects of programming language syntax. So you can see in the example itself that the algorithm is written in very simple English language with different steps. So first step is start, then second is create a variable to receive the user's email address. So you can see that there are no technical details involved in this representation. The second representation that we have is pseudocode. So this representation is very near to generalized syntax of programming language. It provides clear depth of nested statements and repetition of statements. Pseudocode bridges the gap between the natural language representation and the programming language. It is more precise. And the last representation that we have is the flowchart. So a flowchart is a graphical representation of an algorithm. It uses a standard set of symbols to represent the flows of operation. So you might be saying that if I'm writing a code, why should I represent the algorithm in these different ways? So let us say you're working for a particular company. You work there for 3 years, right? And after 3 years, you are moving to some other team, or you are moving for the same company to some other location. So once you go to the other location, that position is filled by any other employee. So when he comes there and he starts working on that particular project or an algorithm, he won't understand anything because it's very hard for a new person to understand a code written by a third person, right? So this algorithm will basically help him to understand the flow of the algorithm, what exactly he's doing, where he has stuck, and what are the loops, what are the functions. So he can get a rough idea once he reads this natural language pseudocode or flowchart. So this is the reason why we need to represent algorithms in any one of the format for the documentation purposes. So now that you have understood the different representation of algorithm, let us see what are the types of algorithmic complexities. So the first one that we have is time complexity. So a goodness of an algorithm is often determined by the time complexity. Time complexity is the most fundamental component of the analysis framework. The valid algorithm takes a finite amount of time for execution, and the time required by an algorithm to solve a given problem is called the time complexity of an algorithm. Time complexity is a very useful measure for the algorithm analysis. The next type that we have is the space complexity. So whenever we are solving a problem using a computer, it requires some memory to hold the temporary data or the final result while the program is in the execution. So the amount of memory required by an algorithm to solve a given problem is called as the space complexity in an algorithm. So there are two factors which actually control the space complexity. The first one is the fixed size components and the second one is the variable size components. So fixed size components are the ones which includes the programming part where your memory is fixed. So it could be the instructions, variable, constants and arrays. And the second one is variable size components, which includes the program whose size depends on the problem being solved. So depending upon the problem, your variable size varies. So then example of this could be the size of the loop, then the stack required to handle the recursive call, dynamic data structures like linked lists. So these are the parameters which play an important role to decide the space complexity of an algorithm. So once you have a different algorithms, so these two parameters, the time complexity and space complexity, plays a very important role in finalizing which algorithm is best for the given problem statement. So I hope you have understood whatever you have studied. So we started with what is algorithm, then we discuss why analysis of algorithm is important. Then we studied the different fundamental stages of problem solving, different characteristics of your algorithm, then different representations of your algorithm, and then we saw the types of complexities in your algorithm. So I hope you have enjoyed the lecture. So this is a small homework for you. So what is the basic difference between algorithm validation and algorithm verification? So I request you to give the answer for this question in the comment box, and I'll verify it and let you know if your answer is correct. So thank you so much for your patience listening. So please stay tuned for the further lectures. Thank you. Have a great day.